discuss arrays now. Arrays is actually very important. In programming, arrays is something which is actually used on a daily basis. So, coming to arrays, what is array? Array is actually a fundamental data structure. Fundamental data structures in programming that store collections of the elements, typically of the same data type. It depends on what kind of language you are using, so it depends. The syntax of declaring an array depends on program to program and language to language, but it's typically of the same data type and in contiguous memory locations, and it can be thought of as a list or a sequence of items where each item is positioned at a specific index, allowing for efficient access and manipulation of those particular items. And also you can think of an array as something as a grocery list. So as a grocery list you have dairy products, right? Now dairy products are you can create an array of dairy products. Dairy is the particular data type. Let's say dairy equals to dairy products equals to integers, right? Dairy products are integers. Now think of it as a data type. Actually it's not an integer, it's actually a data type. Dairy product is a data type. The array elements can be milk, curd, and other milk products, right? So dairy products is the data type and milk and curd is the elements of that particular array, right? Now in this array the data type is dairy product, which can be integer, float, or anything else, and the elements will be of the same data type. If the data type is integer, the array should be 1, 2 and whole numbers, right? 1, 2, 3, 4, 5, 6. If the array is a float, it should have only float numbers 3.5, 3.6, 3.8, and so on. If the array is of strings, it should have name. Let's say it's an array of names, so the strings would have names like any name, right? Any collection of names. So this is basic. I think you've got that, right? So in this example, milk and curd both are made from dairy products. So both share the same lineage. So that's how this. That's why I gave this example, right? So why should we use array? Like, why do we need arrays? Why use arrays? Why so much fuss about arrays and why you need to use it? So arrays are firstly efficient, right? It's very efficient actually for multi-purpose. So arrays allow for quick access to elements using an index, which makes operating like searching, sorting, iterating over data very fast. Organization, it actually organizes data like this, right? So it can help organize data in a structured manner, making it easier for you to manage and manipulate large amounts of data. Then we have memory management. Arrays are stored in contiguous memory, which can be more efficient than other data structures that involve pointers or references, right? Characteristics of arrays are like fixed size. In most languages, arrays have a fixed size. Is the fixed size. In most languages, arrays have a fixed size, meaning that an array, once you declare the size of an array, cannot be changed. An array, for example, if you have an array of 10 integers, it will always exactly hold only 10 integers, right? Indexed access. Next is indexed access. You have something called indexed access in programming languages. So elements in an array are accessed using an index which usually starts at 0 in most programming languages, but it can vary from language to language. Let's say, for example, if you have an array number with the elements 12, I'm giving you an example, approximately, let's say 2 3 4 5 8 9 whatever, 8. So the number 0, like number this statement calling this particular array 0, this is actually a number, this number 0 would access the second element, right? Sorry, the second element, I meant second, this second, right? It will access the first element. So 0 means the second integer, which is the first element. 3 is the first element. Okay, let me make it more conclusive for you. Think of it like this. This is the this is the first element is always indexed as 0. Second element is indexed as 2. Third element is indexed as 2. Okay, let me create a table. This will actually help you understand a little bit. No, this is 0, this is 1, this is 2, this is 3, right? You got the point, right? Now if I index the number 0, I will get the element 2. If I index the element 1 here, I will get the integer 3. If I index 2 element, I get 4, 3, 6, 4, 5, 5, 8, right? Now I think you have got that, right? So yeah, Okay, so then we have a concept which is called homogeneous elements. Arrays typically store elements of the same type. For example, an array of integers will hold integers and not a mix of integers and strings. Then we have type of arrays. One-dimensional arrays, the most basic form, where elements are stored in a line or list like this. Sorry. And then we have multi-dimensional arrays. This is a multi-dimensional array now. Right. I'm gonna put these columns here, which is actually not this ones, but these. Right. So multi-dimensional arrays are arrays of arrays where each element is itself an array. So the most common type is the two-dimensional array, where which can be visualized as a grid or a matrix in mathematics. A 2D array could represent a table of rows and columns, right? So it will have these. Actually, this is how arrays are. We define the column. It will have like this. Yeah. And then I will have one more here, and one more here. Right. This is multi-dimensional kind of an 2D array, which is kind of similar to a grid or matrix, right? Then we have dynamic arrays in some programming languages. Dynamic arrays like Python's list or Java's array list can grow or shrink in size as and when needed, unlike static arrays with a fixed size. So mostly common types of operating on arrays is accessing elements. You can access an array element using its index. This is actually very fast. This operation is actually very fast. Typically 0, 1 in time complexity, which is what we were doing here by this example. Updating elements is something which is kind of an operation that we do on arrays, right? So you can change the value of an element by accessing it via its index and assigning a new value. Iterating over arrays, looping through an array is a common operation, allowing you to process each element individually. This can be done using loops or such as for, while, or else for loops in various programming languages. Also for searching, you can search for an element in an array using linear search or binary search if the array is sorted. If not, it's a different case. Sorting and arrays can be sorted using various algorithms like quick sort, mega sort, or bubble sort, or depending on the programming language and the specific needs. Inserting and deleting in static arrays, inserting or deleting elements can be expensive because it may require shifting other elements to maintain order. In dynamic arrays, these operations are more flexible, right? So some advantages of arrays, is it's actually very efficient. Arrays are very efficient, right? Arrays allow fast access to elements, which is crucial for performance critical applications, multiplayer games or something related to banking or software, right? Then it's very simple. The simplicity is very, very needed in programming languages to make things simpler, because things can get very, very complex, and coding is something which can get complex very fast, very quickly in a week's time. So arrays are actually fun to use because they are very simple and easy to understand and use, making them a go-to structure or a go-to data structure for beginners, and in situations where mostly complex structures are very unnecessary. Most programming languages, or most softwares are built in very simple concepts, you know, where it's very easy to use those or code further in those. Basically, in a layman's word, even though we know programming and how programs work, we try our best to keep it simple, right? It's something related. It's something very similar to banking. You know, a finance person who knows banking will understand the jargons and things that is included in finance. So that makes it very, very complex even for a very experienced financier or a very experienced finance person. That's something similar here, right? Even for a very experienced coder, things can get difficult very quickly, right? So you have to manage resources, manage the simplicity, and make structures very, very simple as it can get, because it's actually you that are at a loss if you make things very, very complex, right? So yeah, it's like a pipeline of your code, right? Arrays are like a pipeline of your code to make it as simple as possible. So the crucial point is always try to make your code simple, and simplicity is actually a man's greatest gift, because we have grown so complex in today's world. The more simple you make things, the more accessible and good it is for you, right? Then we have memory management. Arrays are stored in contiguous memory locations, which can be more efficient than other data structures. There are some limitations of arrays, which makes it easy to go solution, but not an all-in-one solution. So then we have the fixed size. Once the size of an array is defined, it cannot be changed in most languages, which can lead to wasted memory if the array is underutilized or to inefficient capacity. So if the array is overfilled, that is one of the limitations. And then we have homogeneous data. Arrays are typically restricted to storing elements of the same data type, which can be limiting, right? In scenarios where you need to store mixed data types, like a person's description or a person's information. It can be an integer, it can be like age is an integer, name is a string, right? Male or female, F or M is a character, right? So yeah. Insertion and deletion overheads. Insertion or deleting elements in the middle of an array can be insufficient because it may require shifting other elements. So some real world applications of arrays is storing data firstly and foremostly. Arrays are commonly used to store lists of items like the scores of students, names of products, or the pixels in an image, right? Then we have it for buffering. Arrays are used as buffers and data streaming or networking, where data is temporarily stored or being processed or transmitted. Then we have algorithm implementation. Many algorithms, especially involving searching and sorting, rely extremely heavily on arrays due to their efficient access patterns. So some best practices for working with arrays is like initialize arrays properly. Always ensure arrays are properly initialized before use to avoid unidentified or undefined behavior. Choose the right size if working with static arrays. Choose the size carefully based on expected usage to avoid memory wastage, overflow issues. Mostly in software development, we focus on memory wastage and memory usage because everything about software is memory, right? There's limited memory or a limited RAM or a limited drive on a particular device, right? There's only so much you can store. You cannot store infinitely, right? So memory allocation and choosing the software development part, you will realize that memory can fill up very quickly and very it can overview very quickly. So always choose the right size. Working with static arrays, choose the size carefully based on expected usage to avoid wastage memory and overflow issues and over usage of memory allocations, right? Use dynamic arrays when appropriate. For application where the size of data changes frequently, consider using dynamic arrays or list to handle the variability. So arrays are actually very powerful and essential data structures in programming. So they are actually very essential. They provide a way to store and manipulate a collection of data efficiently. Understanding how to use arrays effectively is a fundamental block for any programmer, as they're a building block for more complex data structures and algorithms. So this is arrays is actually something which starts the data structure path, like, right, in programming. So this is a very basic block, and mostly it's widely used because it's very efficient, and we will be discussing how it's very efficient in space and in time, right?